First of all, there are various package managers for Mac, but in my case, I use a package manager called Homebrew. The same goes for Windows and Linux. Each operating system has several types of package managers. However, it's better to use a single type of package manager whenever possible. This is because mixing different types can lead to conflicts or other issues later on. In my case, I use Chocolatey on Windows and Homebrew on Mac. I will explain Homebrew here. If you go to this URL, you will find the script on the home page. By clicking the button, the script will be copied. You can paste it directly into the terminal and run it to install Homebrew. I already have Homebrew installed, and within Homebrew there is something called Cask. Cask allows us to install desktop apps using this package manager. So instead of searching for each program on their home page or the iTunes Store and installing them one by one, I can check if the app is available in Cask and install it directly from the terminal. The reason I'm explaining this is that to set up a React Native development environment, the first thing we need to do is install the Android SDK and Android Studio. I just have Android Studio. So as you can see here, it is like this. By entering brew install Cask Android Studio, you will install Android Studio. After Android Studio is installed, when you run it for the first time, it will ask you to install the Android SDK. You can simply confirm by selecting Yes, and then proceed to install the Android SDK. Next, you need to set up the environment variables related to Android. In my case, I use ZH. Here is the script for ZH, and then next, I have created a dedicated script file in the scripts folder under my home directory. As you can see, I have set it up so that the script runs from the bottom here. In fact, I have set environment variables, including those related to Android platform tools, and inserted them into this environment variable. Additionally, when working on builds, an environment variable called Android SDK root is required, and I have set that up as well. Now, we need to install Java to build for Android. We need to use Java version 8. You can install it through Cask with the command brew install cask temurin 8. Since we're at it, let's also install Java version 11. So please install both Java version 8 and Java version 11, along with any related kits. In my case, Temurin, which I mentioned earlier, is already installed, and Java version 8 is also installed. In the terminal, you can find it under USR, Java, Home. If you search for a capital V like this, it will display the versions of Java that are currently installed on my Mac. As you can see, Java version 1.8 is currently activated to make switching between these versions easier. I use a command called javalist. When I type javalist, the list appears immediately. I developed a custom function that I named JavaChange. This function is specifically designed to facilitate the process of switching between different versions of Java. For instance, if I need to transition to Java version 11, I can easily execute this function, and it will seamlessly update the system to Java version 11. This ensures that the desired version is correctly installed and operational, right? In Java, change 6.8. For Java version 11, you need to use 2 hyphens, and for version 8, you use 1 hyphen. In this way, I can change the Java version more easily. When we use Android, we need Java version 8, but there are times when Java version 11 is also required for other tasks. So, taking that into account, I have set up the command as a function, and I have made it so that Java version 8 is activated by default when the terminal opens. Next, there is a package to install called brew install strcpy. What this does is, when you enter strcpy, the mirroring program will run like this. This is my actual Android device, and the mirroring screen appears on this Android device, allowing me to control it directly from my Mac. This is very convenient for Android development. So, it would be good to install the mirroring feature with brew install strcpy. Next, React Native is developed using a scripting language. Therefore, Node is installed. Of course, Node is generally installed by default, but in my case, I use a Node version management tool to manage different Node versions for each project. So, what is used at that time is NVM. If you go to the home page, you will be directed to GitHub page, where you can find the script under the install section. Simply copy and paste this into the terminal and just press enter to easily install NVM. Normally, to activate NVM, you would need to add the settings to your bash or G shell script files, but once it is installed, it is automatically and seamlessly inserted without any hassle. As you can see, this is indeed related to NVM, so it gets inserted automatically and seamlessly. So in my case, since it is already installed on your system, if you type nvm-ls, it will display the Node versions currently installed on your local machine, as well as the LTS versions that are also currently available for installation. For reference, it is recommended to use Node version 12 and the LTS version for React Native, such as the latest. So, I use Node version 12, and I always check the latest version among Node version 12 by running nvm-ls every time I start a new project, and I use the latest version at that time. In this case, if you already have 12.2.10 installed locally on your machine, you can use nvm use 12.2 by using the command on your local machine. However, if it's not installed, you can install it by running nvm install 12.2.10 and then successfully use it. After installing the corresponding Node version on your system, it gets activated. For me, the activated Node version is displayed clearly in your terminal window. Since this is the initial setup for Node, you can run npm install gyarn, which is one of the popular Node package managers available. So, since I also use Yarn, please set up and install Yarn in this way as well for your convenience and ease. Now everything is completely ready and prepared. We will create a project folder related to React Native using the command npx react native init serial gom. Just a note: when setting the project name, you cannot set it as serial com like this. You can set it in camel case such as serial com, and then enter template React Native template TypeScript successfully and efficiently. Please, oh, I just entered it simply, and unfortunately incorrectly here. It's not a template mistakenly. By adding one more pipe, I set up the template for React Native init. You can choose to include this template or not, but I included it because I use TypeScript. I downloaded the template and am currently installing each package. In my case, it relates to CocoaPods, but honestly, this isn't very important. CocoaPods is related to the iOS package manager. So here, I just set it to gem, and even if there are errors, you don't need to worry about it. And now it's completed. The CD, serial, and COM folders have been successfully and efficiently completed. When I get in here, the first thing I do is create a file called nvmrc. The command echo 12.22.10 can nvmrc is used to display the version 12.22.10 in the nvmrc file, ensuring the correct node.js version is set. This is the file that provides the node information for the corresponding project. So, when you type nvmuse, while having nvmuse available, it switches to the node version that matches the nvmrc. So this is done. And now I will just go ahead and run it. First of all, in the mirroring program I mentioned earlier, I type W. This action is crucial as it ensures that the screen remains constantly illuminated and active, preventing it from going into sleep mode or turning off. Now, the mirroring program has appeared on the screen, ready for use. In this state, I will carefully move it all the way to the left side of the screen, ensuring it is positioned correctly, and then search for it again to confirm its location. After successfully bringing it up again, I will once more move it to the left, making sure it is aligned properly, and then proceed to launch the mirroring point using the command slcpiw. This command is essential for initiating the mirroring process. Then, if you click on Yan Android, which is a critical component of this setup, it will build and run here, allowing the program to function as intended and providing the necessary output on the screen. Right now, I just installed it, and the React Native project is running on the Android device. In this session, we discussed how to connect various devices, including Android and Arduino, to hardware. However, practically, we focused on enabling you to develop for embedded Android. I explained how to set up the development environment for creating Android apps using React Native. Next time, we will look at the development-specific packages that are needed for the project we have created. I will explain the development-specific packages and how to set them up. Then, I will see you next time.